Hello, everyone. It's good evening. Dear authors and invited guests, this is a technical session 6B and myself, Recha from India. And this session will be moderated by me. And on the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 6th World Conference on Smart Trends in System Security and Sustainability. I hope you will enjoy the knowledgeful and interactive session through the day. And there is a special note for all the presenters. In this session, we have a six presentation. Each presentation will be allocate 15 minutes for presentation, which means 12 minutes for presentation and 3 minutes for question answer. And there's a one more request to all the participants. Please kindly stay connected with us with end of the session. So we can take a quick snapshot for making this virtual conference more memorable. So if you have any query and any updates, kindly write it to me in a chat box. Just before we get started, I would like to introduce our chair of this session, Dr. Abdul Kader.
Hello, hi Resha.
Hello, sir. Good evening, sir.
Yeah, good evening.
Wait a minute, sir. Dr. Abdul Kader. He has been worked in several companies that provided system solution in a telecommunication and radio frequency identification in Malaysia, Singapore, and Indonesia. He joined Islamic University of Riau in Indonesia as a lecturer as a Department of Information Engineering since 2015 to continue his research related to the wireless and mobile communication, sensing system, and microwave antenna computer and networking WSN and IoT in 2019. We have he has promoted as an associate professor in informatic engineering, faculty of engineering, Islamic University of Riau, Indonesia. Welcome to you, sir.
Yes, thank you, Resha.
Now we can start with papers.
Yeah.
We can call our first presenter to present her paper on how to achieve balance in the life cycle equation of a building. The paper presenter name is Lizeth.
Hello, good morning. Can I present? Can I start my presentation?
Yes, please.
Okay. I would like to share the screen. Could you habilitate the option for share the screen, please? I can't.
Sorry, please, can you please repeat?
Could you habilitate the option of share my screen?
Yes, you can. Please check. You can check the share screen button is here. You can click this point, click this button, and you can share your presentation.
Yeah, but I click the button, but it doesn't allow to me.
Can you please try again?
Okay. Yes, I can now. Thank you. Well, good afternoon or good evening in London. Good morning and Central America. My name is Lizeth Rodriguez. I'm a lecturer researcher in the university in Central America. I would like to present some of the results of my doctoral thesis a little bit. And I would like to present to my director, Adrián Muros from Barcelona, Spain, and co-director, Oriol Paris. Okay, this presentation starts with a question: how to achieve balance in the life cycle equation of a building? Well, we can see that LCA, of life cycle assessment methodology analysis, carry out for experimental and research purpose, report that the environmental impacts derived from the materials and construction system are greater than the impacts generated in the useful life of the buildings. This is due to the dependence of fossil resources and the energy required for the transformation of raw materials into the we can see that the buildings are the guilty of the 40% of energy consumption, 30% of the consumption of raw materials, 33% of emission from the other sectors, and 25% of waste generation. Well, according to the European regulatory framework, every building must declare energy expenditure in its operational state. And for this, it is required the incorporation of high performance materials, but of high environmental cost. The construction and reversibility is seen as a strategy to avoid impacts and at the end of the life cycle, especially in buildings that have been optimized with premises of energy efficiency and industrialized construction. Levels is a European framework. It's new, and this year was thrown up by the UN, the European community. According levels indicators, it is important to study design that facilitate future reuse and recycle at the end of the building's useful life. To broaden this perspective, it is important to take into account what indicator 2.4 instruct above the concept of the construction, which is implied easy of disassemble, easy of reduce, and easy of recycle. The methodology used in this work is a life cycle assessment of 3 buildings representative of the design criteria expressed in table under the cradle-to-cradle approach, considering manufacturing as the cradle and the reusing scenario as the second cradle, evaluating the circularity of the components classified as critical element, which is the structure. We can see the criteria in this table. The words appear: efficient, optimized, optimized to prolongation, designed to adaptability, and designed for the construction. We're looking for this characteristic in the case of this on the cases. Well, a detailed breakdown on the dimension, this density and masses of the components of 3 buildings has been made, as well as the results of the energy certification obtained from the 3 executive projects. It has also taken into account the life cycle stage according the UN standard in all the phases A, B, C, and even D. Well, for the life cycle projection, the embodied carbon database, the circular ecology ICE database, and the circularity coefficient of level indicators have been taken into account. The EPD and the ITEC environmental database have been consulted to contrast the carbon footprint data of the main materials of the building structure. I take in account a lot of database and contrast each other. The hypothesis. The research hypothesis is based on the fact that it is possible to find the balance in the life cycle equation of a building, establishing a maximum range of carbon footprint and balancing the carbon in each of the stages through the closure of material cycle and the design for the construction, which has allowed the tracking and recovery of material and the end of the useful life of the building. So the end of the life of the building can be the beginning of another. Well, these are the equation. The main equation is the number 1, and in my hypothesis is the number 2. Introducing the new concept, new life. How? Well, using recycled process and design for the construction. Equation 2 synthesize extraction and manufacturing as fabrication and contemplates it in the operation, the energy consumption, maintenance and remodeling scenarios, as well as the potential for energy generation. That is the case of NZ building. On the other hand, the new concept is notorious, new life. That implies the evaluation of the potential to avoid impacts by the following concept according to the UN standard: reversibility and durability. The characterization of the analyzed building in the previous step being in these 3 hybrid type buildings. There is a structural system with the first level of reinforced concrete, and the rest of the level have been built with alternative construction system, for example, wood, concrete, and steel. We can see the percentage of the group of the component in each building. For example, first one is concrete, and another one is wood and concrete, and the third one is steel and concrete. We can see that the envelope is the major. It is the component of the building which have major footprint carbon. Well, a life cycle projection has been made based on the data of embodied carbon, estimated maintenance state according to the recommendation made by the design code, as well as the end of life scenarios have been foreseen, taking into account the durability and background study in the industry. The emissions from the energy consumption of fossil resources have also been estimated, and following equation 1, the total carbon in the life cycle of the 3 buildings has been obtained. We can see in this graph the life cycle assessment of the 3 buildings, and we can see the summatory at the end. It's notorious that the concrete, this is a precast country building, which have the higher results of footprint carbon. To assess circularity and the potential to avoid impacts as benefit to the limits of the system, an evaluation of the potential to avoid impacts has been carried out, both by the generation of energy from renewable sources and by the application of the circularity factor of indicator of levels, obtaining as a result a decrease in the total carbon footprint for a period 50 years of useful life. It is notorious that if the building generates energy and apply the factor of indicator of level, the construction system to the end of their life, they can reduce the footprint carbon. Well, there's the interpretation. The 2cc hybrid building is the one that yield the highest data of embodied carbon due to the combination of material of the system. However, due to the durability and reversibility demonstrated, it is building that has the greatest potential to avoid impacts or that can present benefit beyond the limit of the system. It is notorious in this graph that all of them reduce the footprint carbon, but overall the concrete system, the hybrid building 1, WC, and 3, as C have achieved a decrease in the total carbon footprint, thanks to the high recyclability value of the critical points. In this case, the critical points it is the structure according to the level code. Well, but how to achieve balance in the life cycle equation of a building? The reduction in the carbon footprint in the life cycle of a building in a period of 50 years is achieved thanks to the benefits beyond the system, especially in two relevant aspects. In order to reduce emission by horizon 2050. One, the independence of the use of fossil resources in the life expectancy of the building, especially in the buildings, contemplates energy generation capable of supplying what is needed, which is the case of NZEV buildings. Two, the closure of material cycle through durability, reversibility, and recyclability, which are concepts studied in the standard of the guide, the design process, in order to avoid program obsolescence. This picture shows one building in El Salvador, Central America, which was designed by as a NZ building and use materials which have high, very low impact of the environmental. The conclusion, finally, the evaluation of circularity factor provide feedback for future design exercise. That is, it's allow evaluating the design from the potential for the construction, which implies not only thinking about how it will be built, but how it could be dismantled in a controlled way to recover the largest number of components according to the where they have. This picture shows how could be designed for the construction. Put attention in a lot of part of the building, decrease the part using industrialized system of construction and considering saving energy in all of the process. Thank you so much.
Hello, Raisa. Can
Hello.
I get? I asking moderator. Yeah, I think I can continue. Thank you for presentation, Raisa, for the balancing of life cycle in the building. So maybe I just query about. Do you calculate how much carbon saving or efficiency? Maybe for any material. How many material that in your experiment or your research?
Thank you.
Yeah.
Thank you, Dr. Kadir. Thank you for your question. Yes, of course, we calculate the footprint carbon in all the stages using three base of data. And in order to discover the saved carbon, right? We discovered that kind of 40%, we could save 40% of footprint carbon if we design the buildings in a deconstruction way, because we save the raw materials. For example, if we design this building in this year and in a 50 year, we have to dismantle. If we design this building for dismantle in a controlled way, we could have raw material for new buildings in the future. This is the and that action we will save food with avoid impact in the environmental.
I see. Yeah. Thank you. Maybe one more query, because now civil engineering or many people campaigns on the green buildings, and also in your research, is it applicable for any environment? Because we are in the, especially us from the tropical regions, so the material for the balancing is maybe slightly different, or for the non-tropical regions. What do you think about this?
Yes, of course. There are too many differences between the buildings of the tropical areas and hemispheres. For example, I analyzed a building from Barcelona, Spain. Even Dr. Adrian Muros is my director. He is from Spain. He's in Spain just right now. And we analyzed some buildings from in Europe and try to discover how these buildings save energies, avoid impacts using the codes from Europe.
I see.
In order to apply this methodology in buildings in a region, a tropical region, for example, Central America, that is the region that I work, that I live in El Salvador. And there are too many differences because the difference of the weather, right? In Europe, you have a lot of difference a big difference in the temperature, the low and the highest. And in the tropical area, we have the same temperature every year. Then we save a lot of energy. We have sun, a lot of sun, and that the energy is not the problem. The problem is the materials. Because in Europe, sun, there are too much control about the design process and the manufacturing process. And we try to find the balance and to discover which is the key to analyze in a better way the develop and the about the building in this life. Thank you.
All right, thank you for the answer. I would like to ask any question from others. I think our time is up, really over. I think I get back to moderator Raisa. Can we continue to the next presenter? Maybe. Thank you, Eliza, for the presentation.
Now I would like to call. Now I would like to call our next presenter to present his paper on forecast of large environment cycle of economic development. Presenter name is Alexander. Maybe he is absent, so move forward. We can call our next presenter, Dennis, to present his paper on SEMA for Secure Mobile Field Diagnostic for Cyber Physical Systems.
My name is Dennis Ukashev, Tennessee Technological University. I'm glad to present a paper, Semaphore, Secure Mobile Field Diagnostics for Cyber Physical Systems. We did it with my graduate student, Tate Seiler. He's not here today, so I will be presenting. I'll talk about problem statement, novelty, related work, core design, evaluation, and conclusions. So here is the problem statement. It's actually inspired by the snowstorm we had in Tennessee last year.
Sorry, Dennis, I think you got problem with the microphone or sounds.
Can you hear me now?
It's not clear, but a bit noisy.
Some fuzziness. Better now?
Yeah. Better. Yes. I think you can continue.
Okay. So yeah, we had snowstorm last year and there were power outages. And unfortunately, power outages, it's a big problem. It takes time to fix them. So we thought, how can we help maintenance teams to do it faster so that energy supply is restored for buildings, households. So we came up with a solution for mobile field diagnostic system. It It relies on biometric based on the fly key derivation and authentication, role-based access control, and it supports decentralized peer-to-peer data exchange. So we had this snowstorm in mind, so that the solution is good fit for emergency situations such as power outages. Yeah, the problem with existing similar systems, they introduce single point of failure. So if the main server is down, the system cannot operate anymore. Some of them don't have intuitive interaction and lack of fine-grained access control. Since multiple parties can be involved in the data exchange, in this use case scenario, a fine-grained, role-based and attribute-based access control are needed. Our solution relies on near-field communication chips, and we aim it to be decentralized so that the parties can exchange data without the need to have a central authority. The typical use case is that when the maintenance persons comes up to electric cubicle, for example, in the power grid, they can use their smartphone to scan the attached NFC tag and see the sensor values and also associated alarms and alerts. And then the user can share the data with another user, let's say via Bluetooth, phone to phone, when there is no internet due to power outage. And here is the novel part of our solution. So it's biometric based on the fly key generation mechanism. Key is generated on the fly. It's not stored. It's generated on the fly every time when the client requests for data. And we use fine-grained data-centric role-based access control schema. So here is the brief overview of existing solutions. There are solutions for decentralized data exchange, for health monitoring. Some of them are tweaked for medical systems, healthcare systems. Some of them don't support distributed mode, decentralized mode of peer-to-peer data exchange. Some of them have on-the-fly key generation schema, and some store the predefined key somewhere, which makes it less secure. If the key is stored somewhere, then it increases the chance of data leakage, so that the key is stolen. But if it's not stored anywhere, if it's generated on the fly, then it reduces the risk of the key being stolen or leaked. Here is the system architecture. So NFC chip attached to an object that we aim to monitor, for example, electric cubicle in the power grid. Then the client has the smartphone with NFC support. Many modern smartphone models, they do support NFC functionality. So then authentication mechanism takes place in the backend. Unique token is generated for a client's role. And if the role is authorized to see sensor data, the corresponding data will be retrieved from a database and displayed on a user's smartphone screen. Here are the steps involved in the process. The user registers in the system with the biometric secret. We use fingerprints, and also many modern smartphones, they do support fingerprint-based authentication. Then the user configures details of the devices, registers devices in the system, and ID is used as mapping between the NFC tag, or we can call it NFC label or NFC chip, mapping between NFC chip and the actual sensor. It could be power meter, for example, which measures voltages, currents, energies, etc. So then the user configures devices via put requests on the semaphore server. So semaphore server stores the actual sensor data. It could be a small device, it could be Raspberry Pi attached to the electric cubicle, which uses low power from that same electric cubicle. It monitors. And then the user monitors sensors by biometrically authenticating and scanning the device's respective NFC chip. So this is the workflow. The backend of our system, it uses a relational database management system, PostgreSQL, and we rely on RESTful Express API. The system is customizable. It can be used with many types of sensors. So the sensor values are stored in the backend in the relational table using Postgres. A REST protocol and REST verbs such as get, post, and update allow users to populate and interact with the RESTful API, which in turn interacts with the relational database management system that stores sensor data. So it's not stored somewhere on a central server or a SCADA server, which is typically used in large-scale cyber-physical systems. It could be stored on a small local server, which gets energy and power supply from the same electric cubicle, for example, same device it monitors. So if central server is down somewhere, our local server will still be up and running and collecting documents. And in electric cubicles, usually there are reserve generators. So if there is no internet and SCADA server is down, still power grid will be functioning for some time due to the fact it has redundant power generators. So all the sensor values are stored in encrypted form. This is the essential feature. We want to preserve data confidentiality as well as integrity. Cryptography uses the built-in library of Node.js library called Crypto. We use AES 256 encryption algorithm, symmetric encryption algorithm with 256-bit key to encrypt and decrypt data. In symmetric algorithms, the same key is used for encryption and decryption purposes. That's why it's easier to implement on-the-fly key generation. So all the data client needs to do is to derive the same decryption key, which is same that encryption key. So we use cipher blockchaining mode, CBC for better security, and SHA-256 hash function. For fingerprint authentication, we use Apache Cordova plugin, all-in-one. It's included in the front end of the mobile application. This plugin allows standard fingerprint prompts, and it allows to register biometric secret with that fingerprint. The secret is stored alongside the biometric data in so-called TEE, Trusted Execution Environment, in Android or in Secure Enclave in iOS operating system. Currently, our solution only runs on Android, but we plan to port it on iOS as well. So Secure Enclave will be in charge of storing biometric secret. When authenticating, the fingerprint is verified and the biometric secret becomes available for the authenticated party. So this secret is part of the on-the-fly key derivation process. For the key derivation, we follow NIST recommendations for the password-based key derivation. The key derivation function, or KDF, relies on so-called iterations and salts values. Iteration, it's just a numeric single numeric value somewhere between 5,000 and 20,000. So we repeat the process multiple times. It's needed for better key entropy, so that it's harder for the attacker to guess what key did we use. In addition to iterations, salt is applied. Salt is some random value which is used to add more randomization and entropy. Factors that contribute to the key derivation process: it's hash of the biometric secret, in our case hash of the fingerprint, then hash of the unique device identifier. In case of smartphones, there is a thing called IMEI, It's a unique ID of the phone and hash of the ID of the record being encrypted. So these are three factors. Passive NFC chips are used in a system to be monitored. The beauty of NFC chips is that they are very inexpensive. It's about 20 cents per chip, and they are rewritable. So we can use the same chip many times. If we want to apply it on another device, we just quickly rewrite it. It's very easy. We can, for example, rewrite ID of the NFC chip so that it starts pointing to another sensor. There are many rewrite cycles supported, and the price is very affordable. It's about 20 cents per NFC chip. So there is a unique mapping between NFC chip and the sensor. So when the user scans NFC chip attached to a monitored object, the request will be forwarded to the database, to the right table that stores data for a given sensor. Another feature of NFC, it has distance limitations. You need to bring your phone really close to the chip, about 4 feet or 10 centimeters, no longer than 10 centimeters away. So some stranger who passes by will not be able to do it, because you need to come really close to the chip firstly, and then you have to authenticate. So for a non-authenticated party, fingerprint authentication will not pass because biometric secret is not registered. It's not in the database.
Dennis, you had 2 minutes for the presentation.
I'm wrapping up. So this is how front end looks. It's a mobile app. We use jQuery and Bootstrap. Another thing, for overlapping role, we use the concept of sub-role keys. So if two different roles must have access to the same sensor subset, there are sub-role keys. So it will solve the problem of different roles getting access to the same data subset encrypted with, which is stored in encrypted form. And this is evaluation part. We evaluated time to decrypt the data. It's very fast, 0.04 milliseconds to encrypt for 16 bytes AES-256. It's the mean value of 500 runs. This is the time for key derivation depending on number of factors. So with 3 factors contributing to the key derivation, it's only 0.02 milliseconds. So, and this is time to retrieve records from the database. So for 5,000 records, it's just 0.1 milliseconds. It's pretty fast. So in the future, we will finish containerization so that users can share sensor data in the form of secure data containers with each other. And that sharing can take place, for example, via Bluetooth when internet is not available, when internet is down. Currently, data is contained as JSON data in encrypted 7-zip containers. So users will be able to participate in peer-to-peer data exchange in a decentralized fashion. So this is the main future work. And I'll be glad to answer your questions.
All right. Thank you for the presentation, Dennis. I think I just continue. First, let's get other audience. Is there any question from other audience about the security for mobile field diagnosis? Oh, if no, I just one question. You use NFC for the NFC sensing sensor. Why you consider use, since NFC got limitation the distance? Do you consider other method or other technology like RFIDs or other sensing methods. Why you consider use NFC? Because they have got limitations, the distance need to close. I think it's yeah.
Very good question. Yeah, we considered multiple alternatives.
Mm.
QR codes. The problem with QR code is that you need to point in the right direction. So you need to know where is that QR code to point to it. And for people with visual impairments, NFC is much easier to work with. Second factor, NFC doesn't require power. It's a passive NFC chip. We don't need to power it. It's like a sticky note. You attach it to the wall and it's ready to go. So, and third reason is the price. So, three of these reasons. It's very inexpensive. It doesn't require any external power. And it's easier for people with visual impairments compared to QR codes.
Okay. Thank you.
And the fourth reason is that modern smartphones, they do support NFC.
Yeah. Current mobile phones, most of the brand is comply with the NFC. I think it's time. Your time is up. Maybe I back to Raisa. Maybe. Thank you for the answer and presentation.
Thank you.
Raisa, yeah, maybe you can continue to the next presenter.
Sure, sir. Now I would like to call our next presenter to present his paper on auto-trained brain increase the variance of the gamma bands sample entropy in the left hemisphere in dyslexia, a pilot study. The paper presenter name is Ganit.
Hello.
Okay. Yes, I can see your slide. You can continue the Ganit. Yeah.
Okay, my name is Dr. Günet Eroğlu. I am an instructor at Işık University, Istanbul, Şile, in Turkey. And today I'm going to present auto-trained brain that increases the variance of the gamma band sample entropy in the left hemisphere in dyslexia, which is a pilot study. And this project originally was funded by TÜBİTAK, Turkish Research Council, and it has received a couple of awards, I can tell you. Okay, first of all, what is dyslexia? Dyslexia is a kind of learning disability, which is a specific learning disability, and it has neurological roots. In the whole world, 10% of people have dyslexia, and fluent word recognition and spelling abilities are affected. And it has been known that there's a deficit in the phonological component of language, and it affects the reading comprehension, and it reduces the reading experience and reading speed. And there's a disconnection hypothesis for dyslexia, and it is known that there's a weak connectivity between anterior and posterior brain regions, especially in the left hemisphere. Okay, so our motivation is that actually we have done a couple of clinical trials with auto-trained brain, which is a mobile application, and it uses the neurofeedback principles and multi-sensor learning principles. And this study is a kind of collection of the data from the children with dyslexia, which is 21 subjects, during 100 neurofeedback sessions, and we just looked at whether there were any improvements in the gamma band sample entropy. And it is known that the gamma band frequency deficits are there for dyslexia. And also we know that the gamma band frequencies show the short range synaptic connections and especially cognitive abilities and also the memory. If you compare dyslexic brain structure with autistic brain structure, you can see that the cortex thickness is less than normal structures for dyslexia, but the connection between the left hemisphere and the right hemisphere is increased. So auto-trained brain has a headset with 14 or 5 sensors, and it's a mobile application which can be run on iOS and Android. It is currently being on sale for more than 5 years, and more than 3,500 users have used auto-trained brain at home for their children without any side effects. It is clinically proven that it improves the disconnection syndrome for dyslexia. And how it works, first of all, the children just wears an EEG headset with the help of his mother at home, and the EEG signals are read and transferred to a mobile application through Bluetooth, and it's processed. Some neurofeedback protocols are being applied. There's an AI-based algorithm which also shows some reports about the child's progress, and we provide real-time neurofeedback and also multi-sensor learning, and there's no harm, no side effects. Our novel neurofeedback method just includes that reducing theta and delta waves at Broca and Wernicke region, and also reducing the maximum absolute power of theta waves wherever it has been found in the left hemisphere or the right hemisphere, because dyslexia is a kind of spreaded situation through the brain. And our clinical trial had more than 40 children for 60 sessions, and currently 400 paying users are being in the market for Turkey. And it's a patented technology with a PCT patent. So for this work, we have just gathered the pre and post sample entropy measurement results, especially on the gamma band. And we have used 21 subjects data for this one. For 100 sessions, they have applied this mobile phone application 3 times a week. And our hypothesis is that neurofeedback and multi-sensor learning improve the gamma band entropy in people with dyslexia. And this is the results. Actually, we have plotted a regression line. First of all, we have calculated the sample entropy for each bin. Actually, we have just combined 100 consecutive sessions in a bin, actually, and there were 10 bins because we have used 100 sessions of neurofeedback data and divided it into 10 bins, and we have calculated the variance of gamma band sample entropy for each bin, and we have plotted a regression line. Excluding the first 30 sessions, we can say that there is an increase in the variance of the gamma band entropy, and including the first 30 sessions, there is still increase, but we see that for the first 30 days, there's a huge adaptation happens in the brain for the children. So our results show that the variance of the sample entropy increases rapidly for the first 30 sessions. And we have asked why this happens to the neurology experts, and they said that there are many metabolic changes which takes place in the brain during neurofeedback and during the adaptation period. and the learning effort is really high for the children in the first month. And after the 30th session, the variance of the sample entropy in the gamma band is reduced. And we also hypothesize that the pruning and the new cell formation started in the brain. And afterwards, the variance also increases in the rest of the sessions. You can see that there are some pruning phases and there are some increases in the variance. So the results indicate that the human brain spends more effort in the learning phase in the first 30 sessions, more than the following periods. And there's an adaptation and learning phase, followed by a pruning phase. And the learning continues with some variations included. And in the overall, you can see that there's an increase of the variance, which is the ultimate aim of the rehabilitation, physical rehabilitation, actually, because we just increase the, how should I say, we just increase the how we use the brain in a better way, okay? And in our clinical trial, we have found that there's a brain maturation delay for dyslexia, and there's a lower complexity, lower entropy in the lower temporal scales, which also shows the brain maturation delay. And also there's a mini columnopathy and inflammation. There may be inflammation as well. And if there's an inflammation, it just increases the complexity at lower temporal scales, namely gamma brain. And we can see that neurofeedback just improves the brain maturation and reduces the inflammation in the brain. And of course, there's a limitation of the study. We had 21 participants, and also there's a placebo, and there may be a placebo and maturation effects. Thank you very much for listening. If you have any questions, I can answer your questions as well.
Yes, thank you, Kenneth, for the presentations. I think I just open to the other audience. Any question from other audience about the Kenneth presentation just now? Okay, no, I have question. Based on your testing or experiments, how is the successful rates? How many samples of you test? How many people? I mean, on your experiments?
Yeah, for this experiment, we only counted 21 people. For our clinical trials, we had 40 people in our clinical trials, and more than 80% of children just benefited from the neurofeedback sessions, which is a very good sign. And currently, we have more than 400 people using auto-trained brain at home in Turkey.
Oh, okay. I think one more question. You use a gamma band. It seems like a high frequency. Is it any impacts for the health for the peoples? Because since you use high frequency on the gamma bands.
Yeah, actually, human brain is a kind of functions in a non-linear way, in a dynamic way. So actually our novel neurofeedback protocol is just reducing the slow brain waves, but while reducing slow brain waves, you just reduce the high frequency band values as well. But it doesn't mean that you just reduce the gamma band entropy. Interestingly enough, gamma band entropy, sample entropy, it just fluctuates more. So it means that the flexibility of your brain coming from the outside activities out of your brain just increases. So your brain's flexibility increases after the neurofeedback session. Actually, this is what we have found. And this is the ultimate aim of physical therapy, actually.
I see. Oh, I think because I just concerned because my field is on communication now. Under 5G, we use terahertz bands. Some people's concerned about the dangerous the frequency on terahertz on the hertz of humans. So just concerned about this. All right, I think our time is up. Thank you, Garnet, for the presentations. So
yeah, just one note. I mean, human brain doesn't interfere with the 5G or the other Bluetooth or the Wi-Fi because the human brain just functions between 0 and 100 hertz. Even though it is gamma, it is still low frequency compared with the other electrical devices.
I see. Oh, all right. Yeah. Even your sensing put on the head is still okay, right?
Yeah, it is still okay. It doesn't interfere with the Bluetooth and Wi-Fi or the 5G.
All right. Okay. Thank you again for your presentation and answer.
Okay, thank you very much.
All right. I get back to Raisa. Yeah, thank you.
Sure, sir.
Yeah.
I would like to call our next presenter. It's a Kaiser. To present his paper on active learning of programming as a complex subject, applying problem-based learning for computational thinking development model in a high school. I think he's not here, so we can call our next presenter. It's a Carlos to present his paper on impact of technology on eating disorders. I think he's not here. So we have completed all the presentations. So in this session, we have complete. Yes, sorry, sir.
Maybe we have a photo session as you mentioned earlier. Yeah.
Yes, sir. Yes. So actually, in this session, we have completed all the presentations. Three presenter might be he's absent. So I sincerely thank our author for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. Thank you very much. I hope this session was informative enough. And we, on behalf of the whole team, thank you for the support during this session and the previous session. We will be happy to have you in a future 7th version of this conference in 2023. And all the presenter would be getting digital certificates through email within 2 to 3 working days. Further, all the paper have already forwarded to the Springer, so kindly cooperate with the team of WS4. And I also thank our session chair for this session. Thank you so much, sir, for being here and for your valuable time and presence.
Yes. Thank you, Raisa. I also would like to say thank you to the committee of the 6th World Conference on the Smart Trend in the System Security and Sustainability. Thank you for inviting me as session chair. Thank you, Raisa.
Thank you so much, sir. And there's one more request. Please kindly turn on their cameras for taking a quick snapshot for making this conference more memorable. Thank you so much, everyone. Thank you so
Thank
much,
you.
sir.
Thank you. Thank you.
Thank you.
Bye.
Bye-bye. Take care.
All right. Thank you.